Okay, guys, we're going to do the last check your understanding for this chapter on page 456. Okay. The length of human pregnancies from conception to birth varies according to a distribution that is approximately normal, with a mean of 266 days and a standard deviation of 16 days. Okay. Find the probability that a randomly chosen pregnant woman has a pregnancy that lasts more than 270 days. Okay, that is a straightforward z-score, straight out of chapter 2. Okay, so we'll just draw our curve, do all this fun stuff, z-score it. I think we get a z-score of 0.25, run that in our calculator, and we get the probability of 0.4013. So approximately 40%, there's a 40% chance that a randomly chosen pregnant woman will have a pregnancy that will last more than 270 days. Okay? Then it says, suppose we choose an SRS of 6 pregnant women. Let X be the mean pregnancy length for the sample. So basically, take all 6 women, how long were you pregnant, and average up their pregnancy length. Okay? Now, technically, if this was a true sampling distribution, the mean of that sampling distribution of X would be the mean of the population, the mean of all of the sample would be the mean of our true population, or the true mean of our population, which is 266 days. If this sample is an unbiased estimator for our population, and we're going to assume it is unless we're told otherwise. Okay? 3 says, compute the standard deviation of the sampling distribution of X and check that the 10% condition is met. Okay, so our standard deviation of our sampling distribution is going to be the standard deviation of our population divided by the square root of our sample size. So we're going to do 16 divided by the square root of 6, throw that in the calculator, and we get a little, obviously, smaller standard deviation than my original 16 days, because of course my sample size is going up. Now let's check our 10% rule. Is our population greater than 10 times the sample size? Whoops. Yeah, I'm pretty sure there's more than 60 pregnant women. Okay, so pretty sure that 10% rule is satisfied. Okay. 4 says, find the probability that the mean pregnancy length for the women in the sample exceeds 270 days. So this would be, what's the probability that the average of the pregnancies of all those 6 women will exceed 270 days? Because you think about them, they're all going to have different lengths of pregnancies. You know, some are going to be 260, some are going to be 268, 272, maybe 258. You know, you never know. Okay, so will the average of all those 6 pregnant women's, their average pregnancy length exceed 270 days? So it's pretty much the exact same picture, but we're just going to use our new standard deviation based on the sample of 6. Okay? So we'll draw our curve again, put our 270, and this time when we, z-score, we're going to use our sampling distribution, our standard deviation based on our sampling distribution, because this is a sample size of 6. So let's see, we get a z-score of 0.6124, throw that in the calculator, and we get a probability of 0.2701. So there's about a 27% chance that the average length of the pregnancy of those 6 women will exceed 270 days. Okay, so it's a little smaller chance than just the probability of a single woman's pregnancy exceeding 270 days, but that's okay, you know, whatever. It's because of those 6 women, their pregnancy lengths are going to vary quite a bit. But then again, they could all be pretty close, but who knows, whatever. Okay, so I think that's it for that one. Okay, great. All right, see you for chapter 8 later on. Bye.